Okay, we have a set of labeled data, and we want to build a classifier that takes unlabeled data as input and outputs a label. So how do we construct this classifier? We first need to choose a type of classifier, and it needs to learn from the already labeled data. For this reason, we call the already labeled data the training data. So now let's build our first classifier. We'll choose a simple algorithm called KNearest Neighbors. The basic idea of KNearest Neighbors, or KNN, is to predict the label of any data point by looking at the K, for example 3, closest labeled data points and getting them to vote on what label the unlabeled point should have. In this image, there's an example of KNN in 2 dimensions. How do you classify the data point in the middle here? Well, if K equals 3, you would classify it as red, and if K equals 5, as green. To get a bit of intuition for KNN, let's check out a scatter plot of 2 dimensions of the iris dataset, petal length and petal width. Now the following holds for higher dimensions, however we'll show the 2D case for illustrative purposes. What the KNN algorithm essentially does is create a set of decision boundaries, and we visualize the 2D case here. Any new data point here will be predicted setosa, any new data point here will be predicted virginica, and any new data point here will be predicted versicolor. All machine learning models in scikit-learn are implemented as Python classes. These classes serve 2 purposes. They implement the algorithms for learning a model and predicting, while also storing all the information that is learned from the data. Training a model on the data is also called fitting the model to the data. In scikit-learn, we use the fit method to do this. Similarly, the predict method is what we use to predict the label of a new, unlabeled data point. Now we're going to fit our very first classifier using scikit-learn. To do this, we first need to import it. To this end, we import KNeightors classifier from sklearn.neighbors. We then instantiate our KNeightors classifier, set the number of neighbors equal to 6, and assign it to the variable KNN. Then we can fit this classifier to our training set, the labeled data. To do so, we apply the method fit to the classifier and pass it 2 arguments, the features as a numpy array and the labels, or target, as a numpy array. The scikit-learn API requires firstly that you have the data as a numpy array or pandas data frame. It also requires that the features take on continuous values, such as the price of a house, as opposed to categories such as male or female. It also requires that there are no missing values in the data. All data sets that we'll work with now satisfy these final 2 properties. Later in the course, you'll see how to deal with categorical features and missing data. In particular, the scikit-learn API requires that the features are in an array where each column is a feature and each row a different observation or data point. Looking at the shape of iris data, we see that there are 150 observations of 4 features. Similarly, the target needs to be a single column with the same number of observations as the feature data. We see in this case there are indeed also 150 labels. Also check out what is returned when we fit the classifier. It returns the classifier itself and modifies it to fit it to the data. Now that we've fit our classifier, let's use it to predict on some unlabeled data. Here we have a set of observations x new. We use the predict method on the classifier and pass it the data. Once again, the API requires that we pass it the data as a numpy array with features in columns and observations in rows. Checking the shape of x new, we see that it has 3 rows and 4 columns. That is 3 observations and 4 features. Then we would expect calling knn.predict of x new to return a 3x1 array with a prediction for each observation or row in x new. And indeed it does. It predicts 1, which corresponds to versicolor for the first 2 observations, and 0, which corresponds to setosa for the third.